Dear students, last time we have seen Lewis distribution law and association of solute in either of the solvent and dissociation of solute in either of the solvent and the corresponding distribution laws expressions in it. With this, let us see today numerical problems based on Nernst distribution law and modified Nernst distribution law. Let us see first numerical problem. I read it here. Following data were obtained for distribution of iodine between carbon disulfide and water at 298 Kelvin. Concentration of iodine in carbon disulfide in grams per liter is 41.00, 66.00, 129.00, 174.00, and the concentration of iodine in water in grams per liter is 0.100, 0.161, 0.314, 0.423. We have to calculate Kd, that is partition coefficient between carbon disulfide and water. So let me tell you the hidden things in these numerical problems which we must know at first. So when we read this numerical problem, we will see that in this numerical problem, whatever data given is data obtained in a experiment performed under identical conditions at 298 Kelvin, and the experimental data, whatever experimental data obtained is given here. When we look at the data given here, we will see that there are 4 experiments which were carried out by somebody else in either some academic laboratory like our physical chemistry laboratory or somewhere, and the 4 experiments in this particular case carried out under identical conditions gave the following results. When we look at this data, we will see that, let us suppose this is first experiment, experiment number 1, this is experiment number 2, this is experiment number 3, and this is experiment number 4. We will see that in experiment number 1, the concentration of iodine at equilibrium in CS2 is 41.00 grams per liter, and the concentration of iodine in aqueous layer is 0.100. In case of experiment number 2, we see that the concentration of solute, here iodine, in organic layer is 66.00 grams per liter. On the contrary, the concentration of solute iodine in aqueous layer is 0.161. In case of experiment number 3, we see that the concentration of solute in organic solvent is 129.00. On the contrary, the concentration of the solute is the concentration of the solute in aqueous layer is 0.314 grams per liter. And in last experiment, we will find that the concentration of solute in organic solvent is 174.00 grams per liter, and the corresponding concentration of solute iodine in aqueous layer is 0.423. Once we understood this, next thing is we have to find out the partition coefficient of solute, in this case iodine, between two solvents, carbon disulfide and water. So let us see how can we find out the partition coefficient of iodine between carbon disulfide or carbon bisulfide and water using this data. Now let me tell you here certain important things while solving numerical problems based on either Nernst distribution law or modified Nernst distribution law. We have to read numerical problem very carefully once, twice, thrice, and try to understand what is given in that numerical problem and what is asked. Here the important thing which is to be remembered is we have to see at first the concentration of solute under experimentation in both the solvents and the unit of the concentration. So when we look at this, we will find that here the concentration of solute iodine in organic layer is expressed in grams per liter. When we look at the concentration of solute iodine in aqueous layer, we will find that the unit in which the concentration is expressed is same grams per liter. Therefore, there is no question of changing the unit. The next important thing in this particular case is we have to apply Nernst distribution law and modified Nernst distribution law one by one. Now why this is so? Because we know the solute, whatever solute distribute between two immiscible solvents may exist as normal molecules in both the solvents, or it may exist as associated molecules in either of the solvent, or it may undergo dissociation in either of the solvent or both the solvents. So here when we look at this numerical problem, we will find that we have to calculate partition coefficient Kd between CS2 and H2O. Nothing is said about the dissociation of solute in either of the solvent. Therefore, let us suppose here the dissociation of solute is neglected. Once we understood this, the next thing is we have to apply at first Nernst distribution law to given data and find out the partition coefficient of iodine between carbon disulfide and water. We know that iodine in this particular case may exist as a normal molecule in both the solvents, or it may exist as associated molecules in either of the solvent. So let us see at first how can we find out partition coefficient of iodine between carbon disulfide and water. We know that when any solute exists as normal molecules in both the solvents, the ratio C1 upon C2 is always constant. When solute exists in normal state in both the solvents. On the contrary, when solute undergoes association either of the solvent, in that case the ratio C1 upon n root of C2 is always constant, or we may say n root of C1 upon C2 is always constant. In this case, the solute under examination undergoes association in solvent 2, and in this case we know that when solute undergoes association in solvent 1, at that time the modified distribution law or the mathematical expression of modified distribution law is n root of C1 upon C2. So let us apply at first the normal Nernst distribution law to the given data and find out the partition coefficient of iodine in each experiment. Okay, so with this, let us apply Nernst distribution law to this data and find out what the partition coefficient of iodine between carbon disulfide and water. So let us apply Nernst distribution law to experiment the data in experiment number 1, and the data in experiment number 1 is the concentration of iodine in CS2 is 41.00 grams and the concentration of iodine in water is 0.100 gram. Let us suppose the concentration of iodine in CS2 is C1 and the concentration of iodine in water is C2. So once we understood this, we can very easily find out the partition coefficient Kd in each experiment. So in case of experiment number 1, Kd is equal to C1 upon C2. Here C1, the concentration of iodine in CS2 is 41.00 grams per liter and the concentration of iodine in water is 0.100 grams per liter. So grams per liter cancels and we will find that the ratio C1 upon C2 in this particular case is 410. In this way, we have seen the partition coefficient of solute iodine between carbon disulfide and water in experiment number 1 is 410. Let us see the partition coefficient in case of experiment number 2. In case of experiment number 2, We know experiment number 2 Kd is equal to C1 upon C2. Here C1 is equal to 66.00 grams per liter, and the concentration of iodine in water is 0.161 grams per liter. Grams per liter cancels, and 66.00 upon 0.161, it becomes 409.94. So the partition coefficient of what iodine between carbon disulfide and water in experiment number 2 is 409.94. The most important thing which is to be remembered over here is that all these experiments are carried out under identical conditions and exclusively at constant temperature 298 Kelvin. Therefore, we'll find that in this case, in third case, let us see in case of third experiment, the experiment number 3, Kd is equal to C1 upon C2. Here C1 is equal to 129.00, and the concentration of iodine in water is 0.314 grams per liter. Grams per liter cancels, and we get 410.83. Let us see the partition coefficient of iodine in case of fourth experiment, or we can say that the fourth set of data. Here Kd is equal to C1 upon C2, but well, we are applying normal nurse distribution law, or we are checking whether the given data obeys normal nurse distribution law or it does not obey normal nurse distribution law. How? Calculating C1 upon C2, the ratio of C1 upon C2. We know when solute under examination, under consideration, exist as normal molecules in both the solvents, at that time the ratio C1 upon C2 is always constant. So let us calculate the partition coefficient of iodine between carbon disulfide and water in case of experiment number 4, and here the concentration of iodine in organic layer is 174.00 grams per liter, and the concentration of iodine in water is 0.423 grams per liter. So that unit cancels, and we get 411.35. Now let us compare the numerical values of partition coefficient Kd in each case with each other. We will see that the partition coefficient of iodine between carbon disulfide and water in first experiment is 410. In second experiment, the partition coefficient of iodine between organic solvent carbon disulfide and water is 409.94. In experiment number 3, the partition coefficient of iodine between carbon disulfide and water is 410.83, and in last case the partition coefficient of iodine between carbon disulfide and water is 411.35. When we look at all these numerical values of partition coefficient in experiment number 1, 2, 3 and 4, we will find that the numerical values of partition coefficient are fairly constant, almost constant, and therefore the given data obeys normal Nernst distribution law, that is Kd is equal to C1 upon C2. We need not go for modified distribution law in this case, because whatever numerical values of partition coefficient in each experiment, they are nearly constant, they are nearly equal to each other, and therefore we can say that the solute iodine exists as normal molecules in both the solvents. In this case, the last step in this particular case is we have to calculate partition coefficient of iodine between CS2 and water. So the whatever final answer we have to calculate in this particular case is the mean partition coefficient or the mean distribution coefficient of iodine between carbon disulfide and water. So let us take mean of all these values. How can we calculate mean partition coefficient in this particular case? Take a summation of all these partition coefficients and divide it by the number of experiments. Here this sum of all these values, partition coefficient values, 410.00 plus 409.94 plus 410.83 plus 411.35 divided by 4, because there are 4 sets of data here, 4 experiments are under consideration. Therefore Kd in this particular case is equal to summation of partition coefficient values in each case divided by number of experiments, and here we find that the summation of all these values is 1642.12 divided by 4, and it becomes 410.53. So the final answer in this particular case is 410.53. In this way, we have seen how can we calculate partition coefficient of solute applying Nernst distribution law. I am sure you have understood how to solve numerical problems based on Nernst distribution law. With this, I stop here. Next time we will see next numerical problem. Thank you.